This video is related to linear functions. So we've seen some stuff about linear functions before in previous units, but this will really be focused on graphing them and then finding out some properties about the functions, so like domain and range and the intercepts. So the way that I'll start off these function videos is we'll start with what's called the parent function. So that's just like the very basic initial function. So for a line, it would be y equals x or f of x equals x. Oops. And then we want to just graph that line. So we can graph it using a table of values, or these ones actually you should just memorize. So you should really know or have the parent functions for some basic graphs memorized so that you know what they look like, and then when you're applying transformations or graphing them, then you get the basic shape. So the line y equals x is just a line going through, it's a slope of 1 and it's going through the point 0, 0. Okay, so the domain of this function is related, so domain is related to the x values, okay, and range is related to the y values. So what I want to do is, it's usually easier to see the domain and range pictorially, I think. You can also just look at the function in order to see what it is as well. But here, if I look at the graph of y equals x, the domain is, if I think about the x-axis, how far can my graph go, or like stretch along the x-axis? So if I were to draw a line from my graph anywhere up to the x-axis, like how far could I keep doing that for in either direction or down to the x-axis, something like that. So if you think about it like that, you could go from negative infinity, right? So we could go all the way out in this direction as far as we want, or we could go to positive infinity as well. Okay, so my domain is going to be, negative infinity to positive infinity. Okay, and then my range is related to my y value. So same idea, if I were to draw a line from my graph to my y-axis, how far could I do that? Remembering that my line is extending outwards in both directions. So again, I could go from, my range will be from negative infinity to positive infinity. Okay, and my intercepts, so where does my line cross the x or y axis? Well, they only have one intercept, and it's 0, 0. Okay, so now let's just talk about a little bit more detail with domain and range and the different types of notation that we can write domain and range in. So we have 3 different types of notation for domain and range. So let's just focus on, I'll just look at the domain. So with the graph that we had before, I had the function that I had before, I had the domain of that function was from negative infinity to infinity, and I had it written in this inequality way. We can also write the domain or range in interval notation. So what this would look like is negative infinity to positive infinity with round brackets because I'm not including the infinities. And if I look at the inequality signs here, they don't have equals on them. If they do have an equal, like less than or equal to, you make sure that you put a square bracket in interval notation. And in set notation, I use my curly brackets and I say x, my domain is all my x's such that x is in the set of real numbers, okay, because it can be anything. So these are 3 different ways to write domain and range, and of course this was just the domain that I rewrote here. The one that I actually like the best is interval notation. Sometimes set notation can get a little bit ugly, and inequality notation as well. So interval notation, that's the one that I'll use the most. Okay, so when I'm talking about domain and range of functions, I'm going to actually stick to interval notation. So I just drew out inequality notation in the previous slide to emphasize that domain was x's and range was y's. But from now on, I'm going to use this interval notation. Okay, so let's see some examples of lines and finding their domain and range and intercepts. So the first one I have here is f of x is equal to 2x plus 1. So if I graph that line, I know I could do a table of values if I wanted to, or I can just graph it using it's in slope-intercept form. So I know I have a y-intercept of 1 and my slope is positive 2. So I'm going to go up 2 over 1, and I can go down 2 over 1. Oops. Okay, so there is my line, 2x plus 1. And I want to find the domain of this function. So again, if I look at the graph, I can easily see that my domain, the graph will extend for all values of x. So my domain is going to be negative infinity to positive infinity. My range as well, my line will extend, my function will extend for all values of y, so negative infinity to positive infinity. And my intercepts, so I have an x-intercept as well as a y-intercept. So my x-intercept is here, and my y-intercept is here. So my y-intercept is easy to find. So y-intercept, that is at 0, 1. My x-intercept is a little bit trickier. It's not falling nicely on a number. So what I would maybe need to do is solve for, like set y equal to 0 and solve for x. So if I go back up to my equation here and set y equal to 0, which is this part f of x. So this is solving for your x-intercept. So I move the 1 over, equals 2x, divide both sides by 2. So I get x is negative a half. So my x-intercept is negative 1/2 and 0, which is what that looks like on the graph as well. Okay, but just to be sure, you should do it algebraically. Okay, and let's see one more example. So f of x is negative a half x plus 2. So again, I can do a table of values if I want, or I can just graph it. It's in slope-intercept form. So I have my y-intercept of 2, and my slope is negative a half. So I'm going to go down 1 over 2. And then down 1 over 2. Okay, so that is really messy, but that is my line, y equals negative a half x plus 2. And my domain, again, is going to be negative infinity to positive infinity. So for all values of x. And my range also is negative infinity to infinity. So you might notice a pattern here that for any line, my domain and range is all real numbers. And my intercepts, so I have 2 intercepts, which are easy to read off the graph as well. So my y-intercept is at 0, 2. It was easy to read off the function here as well. And my x-intercept is at 4 and 0. So when y is 0, x is equal to 4. All right, so that's it. Thanks for watching. Good luck with the assignments.